Yo, what up, what up? What's up? How you doing? Morning. Uh, Molweni, kunjani, sawubona, sawubonani, molweni, kunjani, dumelani, dumela, amakuru, uribo, bonjour, goeiemorgen. Just in case you forget one of the greetings, please, man, don't get mad at me. I'll try my best, man. So let's get here to our morning session as usual. One of the guys, he asked me the question. He's an engineer in Sudan. He said, Hamish, I'm having problem, man. I'm writing taste this afternoon, and then I have a question here: how to taste improve the P cities for convergence, and also I want to know divergence because most of the books, they only taste P cities for convergence, but I don't understand how the convergence works. And also, could you please explain to me the divergence of P cities taste? Because most of the books, when I read, they only explain that convergence. So do please, Hamish, break down for me convergence, and if it's possible, divergence. I appreciate. Try to ask my friends, but I'm still struggling. I feel like I don't feel I understand because most of them I feel like they kind of memorize. So please, Mr. Hamish, try the best you could. I appreciate. Okay, let's get back to the question as usual without wasting time. So there's a question right here. I hope everybody can see. It's clearly there. Woo. Okay. So I say taste the P cities for convergence. So we're gonna do convergence, and after that we're gonna do divergence. Let's go. So we wanna taste P cities for convergence. So assume face right. You have a summation of a term, and this term is start. Let's say our term here is 1x power p. So this is our term or our function. Well, let's call it term because this is a series. So we have this p whereby, this x is start from 1, mean this value start from 1 to infinity. So what does that mean, Hamish? Means if you substitute the value of x, let's say x equal to 1, it's going to be 1, means you substitute in here, it's going to be 1 power p. And then we plus, what we plus? Because this value here mean this sign here means summation, so we plus to get the series. Now when x equal to 2, why you say 2, Hamish? Because they say in this summation when you sum, the value of x should change. You should increase this value from 1, 2, 3, 4. But the last one, we don't know where we're gonna stop. Means this is infinity. So now that's why started by substituting or insert the value from x equal to 1. So it's gonna be 1. I'm gonna insert in here 1. So 1 over 1 power p. Now let's increase. It's gonna be 1 over. When this one increase, so it's gonna be 2 power p plus. It's gonna be 1. Now we're gonna increase this value. It's gonna be 3 power p. Let's increase like 4, 5 to 1,000. So we don't know it can be 1,000, 2,000, 3,000. Okay. So it's a lot of times. So 1 over, it can be 1,000 power p or 2,000 power p. So let's assume we don't know that number. So let's call it n. Until what? N power p. Or you can say, oh, the last number. If I had to put the last number, we don't know that number. Let's say n power p. Whereby, what is p meaning? P meaning any real number. I mean, this value p here can be any number. Means this value p can be any number. What that mean, Hamish? This p, it has to be a constant number. What does that mean? We're gonna test now when p is greater than 0. Any number when p is greater than 0, and they want to see our series. Will the series converge or diverge? And also we're gonna test when p is less than 0, and also we're gonna test when p equals to 0, and see if this series diverge or converge. But just for now, you have to know when value p is greater than 0 and the series always converge. For these two, when p less than 0 or equal to 0, always the p series stays. It's always, or all these functions is gonna diverge. Sometimes these two they write like this. Some other book they say p is less or equal to. When p is greater than 0, not 1, my apologies, is greater than 1, my apologies. When p is greater than 1, and the series converge. But when p is less than 1, or p is less than 1, or p equal to 1, and the series diverge. My apologize. So just for now, you have to know when it's p greater than 0, the series converge, and when p is less than 1 or P is equal to 1, the series diverge. So this has to be 1. So let's test now. So we're going to take this function here and test using integral test. So we're going to take a summation. So we're going to test using what? Integral test. We're going to test this P series using integral test. So how we do this? So for this case, you have to say P series for convergence and divergence and integral test. So I'm going to add there, excuse me, I'll say an integral test, an integral test, an integral test, integral test. I hope everybody can see that. An integral test. There we go. Okay, so let's test. Let's go. So now we say we have to let's use the integral test and prove this P series test. So we're gonna say if somebody give you some x equal to 1 to infinity and they have x 1 over p, it has to be 1x over p. If you want to test integral test, it has to be like that. You see what I'm saying? Or somebody could use any other letter here, but it has to be this format, 1 over. Okay, so this time we say in integral test, I'm going to say this time we say integral, but our value start from 1 to, I'll just go quick a little bit, start from 1 to infinity, and then you're going to write your function in here. In a series you can say 10, but in an integral you can say function. So I'm going to say 1 over x power p, but I will integrate x, this value integrates, that's what I say dx here. If you integrate, if you put the value of y, for example, because somebody else could use y, you don't want, and this could be dy integral. If you don't want to say the integral, please let me know. I can have some video for integral, so you can just refer to my videos, and then you'll be fine. So here we go. So now we're going to integrate this one, but now we say this time we say integral 1, and then I'm going to reciprocate that one, negative p dx. See, but before you integrate, remember this is undefinite integral. Definite integral, definite integral. So if this is undefined integral, so somebody cannot see that. Undefined integral, undefinite integral. So if it's undefined integral, why? Because when you integrate most of the time, you want to know your limit. Let's say from 1 to 4, or 1 to 5, 1 to 10, 1 to 1,000, or 1 to anything. But here, see, it goes, we don't know where, to undefined, means to infinity. So that's why we say this is undefinite integral. So we have to make it finite integral. See, we have to make it finite integral. So how we do that to make finite integral? So we say, okay, so I'm going to have to limit this number, this infinity, because we don't know where we're going to start that limit. So we have to assume anything, that it has to be stoppable. Or, yeah, because this is undefined. You go, you don't know where you're going to stop. So you're going to say, okay, so I'm going to limit this to anything. So I'll say, okay, limit n approach to infinity. Somebody could say b equals to infinity, whatever. So I'm going to say this is going to be 1 because I say n to infinity. So here I'm not going to write infinity. I'll say what? I'll say n. But if you assume b equal to infinity, then here you're going to say b, or whichever letter that you're going to assume here. Like I say, we don't want to integrate infinite integral. Phase is going to be, you have to assume this number here to an infinite number. So okay, so we go. Okay, so we have x negative p and then dx. My fault is dx because we integrate x. And then after that, let's integrate. Because this is finite integral, so we can integrate this one because it's a finite integral. Okay, so we have a limit still. Hope everybody can see that. And then n approach to infinity. And then this gonna be, we only gonna integrate this part here, dx, and integral is gonna fall apart. So negative p plus 1, and this gonna be negative p plus 1. Our limit, we don't plus c. Why? Because we have our limit, so we're gonna say 1 to n. If you don't have a limit, you say plus c. Okay, let's go next page. Thank you, appreciate for your patience. Okay, so let's go next page. Okay, here we go. So we're going to continue that. I hope everybody can see that. So we still have a limit. I'm going to rewrite the last part. n approach to infinity, and then you say x negative p, x, I'm going to rewrite this, x negative p plus 1, and they have a negative p plus 1, and they have a 1 to n. Next step, look. So we have a limit, but remember this this limit here, this value you have to substitute in x, not in p. From the beginning, look, how do you say p is any real number? P is any real number. So the limit that we're going to substitute here, this is a value of x, not p. So this value here is a constant, means a real number. So it won't be affected by this limit. So we take it back. So say 1 negative p plus 1, and they have a limit in approach to infinity. And this one here will be left with x negative p plus 1, and I'll limit to 1 to n. Okay, so I could substitute this one in. I can substitute, so I'm going to say, okay, go in. So 1 negative p plus 1, negative p plus 1, let's go quicker now. Limit and approach to infinity. Okay, let's substitute in here. So this going to be n negative p plus 1 minus 1 negative p plus 1. But we know 1 power anything equal to 1. 1 power 1000 equal to 1. 1 power Mntwana Wa Bantu Academy, which is this academy, equal to 1. 1 power anything equal to 1. So all this stuff here is complete equal to 1. So okay, so we have 1 negative p plus 1, and the limit n approach to infinity, and then this one here is going to be n negative p plus 1 minus 1 bracket. But then, excuse me, but then it's not okay. But then minus 1. But then, excuse me. So we got minus 1. I can reciprocate this one if you want. I can reciprocate for 1, and that's okay. 1. Why do I do that? I'll tell you now. Okay, limit n approach to infinity. So I'm gonna say, excuse me, if I reciprocate this number here, it's gonna be 1 over exactly the same thing n, but the whole this power is gonna be negative. So put negative out because this is like positive, the whole bracket. So when you reciprocate, it's gonna be negative the whole bracket exactly. That way how it is, just like how you see there. Okay, you see, you take the same bracket and they put negative, because when you reciprocate anything, like 1 over, let's say somebody give x power n, how you reciprocate is going to be 1 x negative n, means exactly the same thing, but this power become negative. Here we go. So now we say I'm going to multiply in, so I still have a 1 negative p plus 1 limit n approach to infinity, and then this is going to be 1, and then we're going to say n positive p minus 1. Yes, because we plug it in, or we set in the value, multiply in, positive n minus 1. Minus 1 here. So now we're going to come and substitute the limit of n now. Next step. So when you substitute n here, this is going to be equal to 0, because you know, look man, if you have a 1 orange, divide by the larger number, what happened? Everybody's going to get smaller. See, you have a 10 rand, you have a $10, $1, and you have a 1,000 people. So if you have $1 and there's a 1,000 people, if you have to split that $1 for 2,000 people, what happened? Everybody's gonna get small. See, and that's why if I have a 1 and they divide by this infinity, the bigger number, positive infinity means very bigger number. Power whatever, it doesn't matter. It's gonna be 0. See, just like 1 divided by 80, and let's say, okay, you have a 2 orange divided by 2 people, what happened? Everybody's gonna get 1. Same orange divided by 100 people. I mean, everybody's gonna get very small piece. But so the more you increase the number of the denominator, means those people are gonna get smaller. So if you substitute this limit in here, this infinity here, this infinity in here, means gonna be 1 over bigger number. Infinity means bigger number. So 1 orange divided by a lot of people, you're gonna get 0, because everybody's gonna get smaller to the, like 0. So we say okay, 1 negative p plus 1. So we don't want to write limit anymore because we plug it in. So all this stuff here is going to be 0 minus 1. So we multiply this negative in. So when you multiply this negative, it's going to be negative 1. This is going to be negative 1. Negative 1 times negative 1 is negative 1, and then negative p plus 1. And then I can flip if you want. Acceptable, yeah. So 1 over, I'll take this negative down. So I'll take negative down, it's going to be negative p plus 1 is acceptable for 1, yeah. So next step, put it in. So 1 over, excuse me, let me just call this. And then it's going to be p plus 1. P plus 1. So finally, let me use the other pen here, excuse me. So excuse me, sorry. So finally we see we have 1p plus 1. So we want to see now 1p plus 1. So we say when this p is greater than 1, and then this is going to converge. Let's taste and see. Okay, put here 2. No, my apologies. This is when you multiply this positive and this on negative terms. This has to be negative, my apologies. So here it has to be negative. So p minus 1, p minus 1, p minus 1. Yes, p minus 1. So let's taste now when p is greater than 0. So I'm going to do this. When p is greater than 0, let's say 5. What happens? It's going to be 1 over 5 minus 1, 4. 4. Okay, let's increase the number. Let's say this is 100. So it's going to be 1 over 100 minus 1, 99. So you have a 1 orange divided by 99 people. What happened? Everybody's going to get smaller. Let's increase the number. 1,000 here. Or 1 million. So you have a 1 over 1 million. So what happened? You have a 1 orange and you or $1 you have to give it to million people. What happened? Everybody's going to get what? Smaller, smaller, smaller. That's what we say when the value p is greater than 1. You see, when this value p is greater than 1, and then this series is going to converge. So, okay, so we have seen when p is greater than 1, the series will converge. See, using the p series test, we have proof using, we have test using p series test and integral test. Okay, let's prove now when p is less than 1 and when p equal to 1. So we know for facts for the next step, we know this p, when this p is less than 1, and then this series is going to converge. It's going to go to bigger number. It's going to converge. We know for facts when this p is less than 1, this series is going to converge. Let's see if it's true. Let's use a p series test, an integral test. Seriously. So now, excuse my apology. So we want to test p series now. We want to test our p series using integral test. So I'm going to say my integral 1xp dx. Where this come from? From our summation, whereby x equal to 1 over xp to infinity equal. So this has to be 1 to infinity. I hope everybody can see there. 1 to infinity. And what we want to do now, we want to test the divergence of p series. Divergence of p series using integral test. So we're going to use integral test here. Use integral test. I hope everybody can see that. If you cannot see, please let me know. Susan. Okay. So let's test for divergence quick. So I'll go speed a little bit because now you know what happened. So I'm going to say, okay, so I'm going to use what? Integral test. So I'll say, okay, so I have my integral. So 1 half infinity the 1x per p d dp. See, but we can, this is undefinite integral. So if it's undefinite integral, we have to change to definite integral. So we don't want this undefined, right? So, excuse me, it's not defined. We don't want this what? Infinity. So we're going to have to limit this to any number. Now I'm going to use other letter because Hamish every time use n. Let me use other letter. So I'm going to say limit. We're going to let this. So we're going to let, let's say b. B approach to infinity. So this meaning is going to be integral, and the 1 to b means it's not going to be undefined infinity anymore. So this is going to be 1 x power p, and they'll have a d. This is dx because we integrate to x, and this is a power here. So d dx. So here we go. Here we go. So now we say our p now is less than, let's assume our p equal to 0. P equal to 0. What is 0? Okay, so now we're going to assume p equal to 0. What is 0? Mean this 0 we know is 0 is less than 1. And what we say on the previous line, that when P on integral test is less than 1, then the series what? Diverge. So let's see if it's true, it's going to diverge when that P equal to 0. So we're not going to leave P, we're going to say equal to 0. So we're going to say, okay, limit. Okay, our B approach to infinity, and that's going to be integral, and that's going to be 1 to B is not infinity, infinity anymore. So 1, and this is going to be 1. It's going to be 0, my point is going to be 0 because the 0 P is less than 1, 0 is less than 1. So we're going to say x power 0, and they say dx. So what happened here? So it's going to be equal to limit n approach to B is not n approach to infinity, and then this is going to be integral 1 to B 1. Any number past 0 equal to 1, so it's going to be 1 over 1. Any number past 0 equal to 1, so it's going to be 1 over 1 equal to 1. And then dx. So we have limit B approach to infinity. Now when you integrate dx, it's going to be x. And then our limit 1 to B. Okay, so what is the next step? We substitute in the limit. So this is the same. We have a limit here, and then our B approach to infinity. Okay, so it's set in the value, so it's going to be B minus upper limit minus lower limit. So we take this B in here, and then we minus upper limit minus lower limit. This 1 is going to go in there. So okay, B minus 1. And then after that, we say this B is a bigger number. So when it's a bigger number, now we're going to substitute this limit here. So if this B is a bigger number, it's going to be bigger number. So we're not going to write limit here, and we'll say bigger number minus 1 is going to be bigger number. 1 trillion minus 1 means still trillion. I don't think it's kind of affected or anything. So it's still going to be infinity. So we have proved and see that when P is less than 1, the series diverge because go to infinity. So it's okay. Oh, I see now. When P, we use a black pen here. When P, on a P series test using integral test, when P is less than 1, and then our series, what happened? Diverge. You can see it diverge. It goes to positive infinity. Okay, let's see now. Let's say P equal to 1 exactly. P equal to 1 exactly. Also, it's going to diverge. Why? Okay, we're going to say again now. P also equal to 1. It's going to diverge also. Why Hamish you said it? Because from the beginning we say for divergence P has to be less or equal to 1. Less or equal to 1. So right here I have proved to you when P is less than 1. When you say 0 means P is less than 1. So but I will say it's equal or less than 1. Let's see when P equal to 1. It also has to diverge. Okay, let me take out the page. Thank you. So we're gonna use we're gonna take this P series test using convergence as well. Okay, so let's see. So now we're gonna test when P equal to 1 exactly. So I'll go quick a little bit right now. So say integral test. So summation, and you have 1 xp, whereby this P start from 1 to infinity. But for this case, we're only going to check when P equal to 1 exactly. So say integral, and then 1 to infinity, but 1 over xp dx, because integral x. But for this case, P equal to 1 exactly. So we say okay. So now we're going to have to limit, because we say we're not going to use an indefinite integral. So this is an indefinite integral. Indefinite integral. So we're not going to use that one. So we have to limit this number here to any value. I'm going to say academy. Mntwana Wa Bantu Academy. I don't want from academy. So it's okay. So I'm going to eliminate this and say academy. Mntwana Wa Bantu Academy. So it's okay. So it's going to be integral. I'm going to limit this academy Mntwana Wa Bantu equal to that one. So I'm going to say integral 1 to Mntwana Wa Bantu Academy and the 1 over xp dx. But how do you say? We say now P equal to 1. So that's going to be limit Academy, Mntwana Wa Bantu Academy, and the integral 1 to a, and this is going to be 1 over just x, because it's going to be power 1. Power 1, so anything power 1 equal to that thing. So x power 1 is just x, dx. So we know this is a ln of x. Whenever you integrate, and put a note here, just when you integrate 1 over Mntwana Wa Bantu Academy, but what do you, let's say you 1 over a, and then you integrate a, so you have to say dA. If you integrate x, you must say dx. So this is Mntwana Wa Bantu Academy, so you have to say you differentiate with Mntwana Wa Bantu Academy, d Mntwana Wa Bantu Academy. So then this is always equal to ln of whatever which is here. So it's going to be ln of a. But a ln, remember, ln, it has to be a positive number, because whenever you plug in, let's say ln of whichever number which is here must be positive for the function to be defining. So if you say ln, let's say 8, yeah, it's going to work. But if you say ln of -2, it's not going to work. So that's why I put absolute here. When you say absolute, means you tell them, oh, whichever number which is here, it must be positive. Okay, here we go. So now we say, excuse me, so when you integrate 1 over x, it's going to be ln of x. So you say limit over a, approach to infinity, and then this going to be ln of x absolute. You have to plus c. No, you can't plus constant because you have a limit. So we're going to say our limit starts from 1 to a. And then after that, we're going to substitute this limit in here. So we're going to say limit a approach to infinity, and then we say upper limit minus lower limit. So we're going to say ln, and put bracket here, ln a bracket minus ln of 1. But ln of 1 equal to 0. Ln of 1 equal to 0. You can plug in the calculator and test and see, but ln of 1 equal to 0. So say ln of a approach to infinity, and this can be ln of a minus 0. See, so this is going to be the same thing, ln of limit, excuse me, a approach to infinity, anything minus 0 equal to that something. Mntwana Wa Bantu Academy minus 0 equal to Mntwana Wa Bantu Academy, so this is equal to a, and that's what we have. So we can substitute in here. So we say, if this number goes to bigger number, means go to infinity, means everything is going to be equal to infinity. So it's a ln of infinity. So this is going to be infinity. Okay, so we see now, when p also equal to 0, when p equal to 0, also the series we see converge. So how do we conclude? We conclude that using p series test, by testing or using by testing or using p series test with integral test, we have seen when p is greater than 1 and the series converge. And when p is less or equal to 1, the series diverge. So done already, right? So thank you for the time. You know, I appreciate the time, man. So I hope you know, I believe you learn from my mistakes, and you know, you have learned something from me, and also you have learned from mistakes. And you know, feel free to contact me. You can leave a comment, and you know, make sure you subscribe, and you click the like button if you think it is deserves. And if you have any question, just feel free, man. You can leave there, you can take a picture, or you can send to me, or you can just do whatever you can and send me the question. I can always solve, man. I can always try my best what I can. Thanks, man. I appreciate it, man. Thank you. And don't forget to click button there, subscribe, and share if you can. Thank you very much. I appreciate it. This is Mntwana Wa Bantu Academy, man. This is how we do it. Thank you.